they weren't replaced, then it would have been dependent. That's the difference there. We're going to get some more practice. Now we're going to work with some dependent probability. So it's that occurrence of one event that affects the probability of another. What I mean by that is, let's say you have a deck of cards and you're dealing them out, or if you were to pick up a card on the top of the deck and you were to draw an ace of spades, you have it and you're not putting it back in the deck. So you have that separate card, but then you go to draw another card, and your probability of getting an ace is an ace of spades. There is no probability of getting it because you have already selected it on your first draw and you did not put it back. So that is where that without replacement comes from. So if you're drawing cards without replacement, or drawing if you're picking anything, I'll say anything without replacement. That's an R for replacement. Again, feel free to pause if I'm going too fast, or if you feel like you're getting it pretty well, then you can skip it. But there will be a homework quiz at the end, so if you skip it, you might have missed something that will help you get an answer right on the homework quiz. Okay, so now we're doing with some dependent probability. So you are about to be dealt a hand from a standard 52 card deck, and they're not replaced after dealt. Okay, so here's that key thing, that they're not replaced. So that's how we know it's dependent. So probability of getting a red card. Well, with our last unit, we know that half the deck is red. So probability of red on the first one is equal to 1/2. And then we have probability of red on the second card. Since we've already picked out a red card, here I'll do 26 over 52. This was before I reduced it to 1/2, but that's 26 over 52 is the same as 1/2. Now, since I didn't replace it, there's one less card. So let's say you drew an ace of diamonds. After you picked out on your first one, there's one less card in the deck. Therefore, and if it was red on the first one, there's one less red card. So that's why I took 52 minus 1 to get you to 51. And then you would take 26 minus 1, because you already had a red card, to get you to 25. So then you have 25 over 51. And then you are going to multiply those events. So you have 1/2 times 25 over 51. And that's going to be 25 over 102. Now for our next example, if you draw a 2, then a 2, then a 2, then a 2. So if you draw 4 2s in a row, so probability of the first 2. We haven't drawn a single card, so we're back to square one. This is a new problem, so we now have all the red cards available to us. Probability of a 2 is there's 4 2s out of a deck of 52 cards, and that reduces to 1/13. Probability of the second 2, because there's one less card now, and there's one less 2, so let's cross out this 2 here. There's 3 2s left, and there's one less card. So 3 out of 51. This is going to be, you'll see that this is going to be very repetitive here now for this next one. Now if we were to draw another 2 on our third try, so we've got 2 2s in a row now. Now we're seeing how many 2s are left. There's 2 2s left, and there's 50 cards left. And then lastly, probability of 2 on the fourth draw. So we'll cross out another 2. So we've got 3 2s in a row. Now we're on the last one. There's only one left, and they're left with 49 cards. So it's 1 over 49. And then you'll go through and multiply those. We have 1/13 times 3 over 51 times 2 over 50 times 1 over 49. And that simplifies to 1 over, it's going to be a very large number. It's 270,725. There would be your final answer. And that was, you'd only do this if they're if they are dependent. Now, we have two problems. This might help, again, just solidify differentiating between the two. So we have 9 red marbles, 3 green ones, and for each case below, we're going to find the probability. Okay. So let's say we have it's saying probability of red and then green. Probability of red, then green. So the first one is if it is replaced. So if the marble is replaced, does that mean it's independent or dependent? Let's think. Yeah, independent. If you said independent, you're right. So that is independent. So probability of red, how many total marbles are there? There's 12 because 3 plus 9 is 12. And there's 9 red marbles. So that probability is 9/12. Now probability of green, if you replaced it, if you're replacing it, you're putting it back in. So there's still 12 marbles, but probability of green is 3/12. And when you multiply them, 9/12 times 3/12, get 27 over 144, which simplifies to 3/16. Remember, you're always going to want to simplify it. And that is independent. And now, if it's not replaced, that is dependent. So probability of red on our first one, since we haven't picked one yet, we still have all 12 marbles. And there's 9 red ones. Now probability of green, if we have not replaced it, so that means there's one less marble. So that 12 minus 1 is 11. So we have, and how many green ones are there? There are 3. So we have 3 over 11. So 9/12, 3/11, it's going to be 9. Well, it's 20. Sorry, I was already getting caught. I was getting ahead of myself and writing the simplified form of it. So that's 27 over 132, which then simplifies to 9 over 44. I want to make sure you can't simplify that further because you might. Let's see. I think that's as far simplified as it can go. So remember, it's independent if it is replaced. It is dependent if it's not replaced. So feel free to email if you have any questions. Remember to complete. So for today, you're going to do the daily attendance form, watch the videos, and do the note quiz. Tomorrow you will do the homework and the homework quiz.